Okay, here we go. Okay, again, I'm not going to read these to you, but if you come back and read these after we finish our lesson, you should be able to do these things. Now, one of the big ideas here is to construct a what? A scatter plot. You know what a scatter plot is? You have an idea? You're going to plot what? A bunch of points. So you will, and they're going to be scattered all over the place like this, and they're not going to form this beautiful line, but guess what? There will be a trend line, that's what they're going to call it, a nice trend line that you should be able to fit right through the center of all those points. So once you make that trend line, our job is going to be write the equation to that line. Have we ever written an equation to a line? Yeah, point slope form, solve it for y, put it in slope intercept form. And then once you do that, guys, then you're going to use your equation to answer questions. They're going to have questions for you in the end about this line that you drew. Okay? Does this ring a bell? Have you ever done that? You should have. You should have done it in Algebra 1, and you should have done it in math modeling. And if you were in geometry, I'm not sure if you did it in geometry. I don't know. I don't remember. Okay, so that's what you're doing, and I'm not going to read the goals to you, so here we go. This is the first page of the notes. We're just doing this page and the next page, and then we're done. Okay. But this page kind of talks about what scatter plots are, so I'll read it to you, and I'll kind of circle some things that I think are kind of important to you. You know, I don't know, you don't have to circle them, but what I circle I know is kind of important for you on the test. Okay. It says graphs. Graphs of data pairs for a real-world situation rarely fall on a straight, perfect line. Their arrangement, however, can suggest a relationship that you can model with a linear function. A linear function is a line. That's all it is. It's just a line cutting through. Okay, sometimes it is possible to model data from real-world situations with linear equations. You can then use the equation to draw conclusions about the situation. So we'll write the equation, and then we're going to use the equation to answer a question. Now, a scatter plot is a graph. Okay, so here's kind of where they kick it into gear. A scatter plot is just a graph. That's all it is. That relates two sets of data by plotting the data as ordered pairs. You can use, what does that say? You can use a scatter plot to determine the strength of the relationship, or what they call a correlation. Now, what's the correlation? It's the strength of the relationship. How strong are the two variables related to each other? Extremely strong, kind of weak, or maybe none. Maybe it's not related at all. Who knows? Okay. The closer the data points fall along a line with positive slope, the stronger the linear relationship, and the stronger the positive correlation. Okay, so let's just take a look at the picture. All right. First of all, why is this considered negative, these two?
Rate of slope.
So you're saying, you're looking at the scatter plot, and you're saying the points go which way? Down. And I mean, if you look at it, it looks like it's going down and down. Okay, why do they call this one strong negative and this one weak negative?
It's closer together.
Okay.
The dots are like slimmer, I want to say.
Slimmer?
Yeah.
Tighter? Would you say tighter?
Tighter.
Right next to the line. The closer they form a line, it's a strong relationship. Where this one goes down, but it's not, they're not tight around the line, they're kind of loose, and so we say this is a weaker one. But they're still correlated. That means they still affect each other. All right, skip this. Go here. Why is this positive? Yeah, both of them go up, up. Okay, and this one is strong because the points, again, are tighter around the line. Here it's weak because they're loosey-goosey. They're all around the line, but they're just kind of, they're not quite touching the line. Okay? Now, look at the middle one. They actually say what? There's absolutely no correlation. at all. You graph, you graph, you graph. Does this line go up?
No.
Does this line go down? Is it horizontal? Is it vertical? I can't tell. So guess what? There's no correlation. This will happen sometimes, and when it happens, you smile. How come you smile?
Yeah.
You don't have to do any work. You just say what? Not related. There's no correlation, okay? So you're kind of hoping for this one, but 90% of the time you're going to get what? Strong, positive, or negative, okay? Strong, weak, I don't know. But you're going to get one of the two, okay? Last paragraph says a trend line. So here's another big word in this section. You got scatterplots, correlation, and now trend line. What's a trend line? It's a line that approximates the relationship between the variables or data sets of the scatterplot. You can use a trend line to make predictions from the data. In the previous lesson, you learned how to use 2 points to write equations of a line to model real-world situations. You can use this method to write the equation of your trend line. You're going to draw a trend line, you're going to write the equation, and then you're going to use the equation to answer questions. We're going to do how many problems? One. Turn the page. Here we go. This is the first problem we're going to do. This is the last problem we're going to do. Okay? Here it comes. All right. Now, last hour, I kept saying, are you with me? Are you with me? And then everybody said, yeah. And then 10 minutes later, they're going, I don't get where you got that part of it. And then where was that part? Way up there. They never asked the question in the first place. Just ask me questions, okay, as we go. Okay, the table below shows the median home prices for Florida. First of all, this is a statistic term. Median means?
Middle.
Yes, it means just the middle. It's not the average. It's the middle of the data. Okay, that's all it means. All right, so the middle home price in Florida. What is an equation of a trend line that would fit through the data that models a relationship between time, so we're going to measure time, and home prices? These are your two variables. What year is it, and how much does a house cost? Use that equation to predict the median home price in what year? 2020. This is the question right here. In the year 2020, how much does a house cost in Florida? So that is basically what they're saying. Okay? Look at the data. In 1940, what's a house median? The median house cost?
23,100.
Yeah, 23,100. Okay, that's 1940. 50 it goes up, 60 it goes up, but in 70 it goes down. So this 10-year period from here to here, the price of a home actually kind of stabilized. It didn't go up, didn't really go down too much. Then 1980 comes and it shoots up. 90 it shoots up. 2000 it shoots up. So it's up, up, up. You can see already it's what kind of correlation?
Positive.
Positive. It's going up, up, up. Okay. Now the question becomes, what does it cost in the year what?
2020.
2020. So there's 2010. Here's 2020. So your job is to get this answer right here. It's that one. Not 2010. Okay. So here's, it's all laid out for you guys. Step one, make a what? Okay. Now, and then it says describe the correlation. We'll do that later. To make a scatter plot, I want you to look at your data. Look at how big some of your numbers are. Like, for instance, you have to graph the year. Now, remember, this is X. This would be your Y-axis, right? The year is 1940. So that means the first point you're going to graph is 1,940. This is the year. Do you want me to, what did you say, David?
You have to do the break.
You got to do the break, and then skip a bunch of numbers and start at whatever. Okay? And I can do that. It will work. Nothing's going to go wrong. But you know what? When it comes to the years, I got to tell you, most math books will do the same thing. Instead of graphing the year 1940, they do something like this. They go, I'm going to change that year to year 0. Because a number line usually starts at what number? 0. But that's not the year 0. It's really the year 1940. So you would have to somewhere on your paper say something like this. When t equals 0, it stands for what?
1940.
1940. So somewhere on your paper you'd have to say that. If you're gonna change the scale, you'd have to do something like this. Write that up. And then you cross out 1940, you put 0. Then you cross out 1950, and what do you put? What? 1. If 1940 is 0, what's 1941? Isn't 1941 1? Oh, you want to go into decimals? I wouldn't do that.
Go by tens.
I would just say, this is 10 years after 1940. I would call 1950 10. Because it's 10 years later. Where 1960 compared to 1940 would be what? 20 years later. So I would cross these out and go 0, 10, 20, 30, 40, 50, right? Are you with me? 60. 2010 would be what? 70. What would 2020 be? Yeah, this is really 80. It's called year 80, but it's really the year 2020. Okay? Now, the reason I did that is because these numbers are so large up there, okay? So that would mean on my scale down here, I'd probably count by tens. So 10, 20, 30, 40, 50, 60, 70, 80. And when I say 80, I mean the year what? 2020, yeah. I don't mean 80 years. There's 20, 30, 40, 50. Okay? Good? Now, could you have done what David said? David said make a little jagged mark and then start at 1940, 1950, 19... Can you do that?
Yeah.
Yeah, you can. You're just going to be working with some huge numbers, but fine.
That's what I did.
Is that what you did? And that's fine. Okay, see, this is why. This is your home prices. Okay, what do you want to do?
You gotta make the other number smaller too, otherwise it's ridiculous.
You could make them smaller. What do you mean? What do you want me to do?
Just go by 10,000.
Oh, you count by 10? Okay. I got to get to 105.
Just go.
Okay. So I would need 10. Yeah, you're right. We'd probably do 10,000. 10,000. 20, 30, 40, 50,000. 60, 70, 80, 90, 100,000. Okay. Okay. Let me just throw a couple numbers in there. That's 70, 80, 90, 60,000. Okay. So there we go. So now when you graph, you just have to look at the numbers. Year 0, which is 1940, but year 0 would correlate to what?
23,100.
And it's really hard to graph the 100. So in my mind, I just think 23,000. Go find it. Where's 23,000? About there. Now that's an about. That's just me estimating 23,000. The year 1950, which is year 10, would be 40,000. Then what? 58,000. I mean, we're climbing pretty fast. Then all of a sudden, we hit the brakes,
Down by 1,000.
and we go down 1,000. Okay. Not much, just a little. Okay.
89,000, so it's way up there.
Almost 90 then. Okay, and that goes with year 40. So there's a huge jump right here.
Yeah, it's ridiculous.
And then 98 is above 50, I guess. Here. Then 105 above 60 here. So there's your scatter plot right there.
You're trying to touch at least 3 points on the line.
No, no,
That's what
don't.
you taught us.
No. Now here's the deal. You got to describe this. Describe the correlation. I always start with it's positive or negative. Positive because it's going up. Okay, and the word strong and weak, strong just means all the points fall very close to my trend line, and weak just means they fall sort of close, not really right on, but let's get the trend line first before we say strong or weak. So to me, a trend line is kind of like this. I look at the data and I go, well, this is kind of like the lower boundary of my data. This is like the upper boundary of my data. So where am I going to fit this trend line? Dead center, right between all of it, right? So let me go like this. Let me grab this. I'd probably go something like, would you guys think that's good, what I have? Is that too steep or too flat?
Too flat.
Too flat and too what?
Steep.
Oh, you can't see it. Steep. So I'd sit in there. I'd go about right there. And you know what? That line, if you feel like that line matches the data, that line does not, I repeat, it does not have to hit any points. It just has to follow the pattern. That's all it has to do. If you're lucky, it hits 2 or 3 or 4 points if you're lucky. You might not hit any. So look at the line. Tell me, what do you think about these points? Are they really close to the line?
Yeah.
This is right on, little off, right on. This one's off, little off, right on. I mean, to me, this is what? Strong or weak?
Strong.
Yeah, this is pretty strong, guys. So this would be a strong, strong positive, right? Good. Sketch the trend line. Check. I already did it, so I'm good. Now, here comes one of the most important parts of this whole problem. Choose 2 points. What does this word say right here? On the line. You cannot just pick any 2 points you want to pick. Like you shouldn't pick this point and you shouldn't pick this point. Why not this? Why not that? They're not on the line, and if you did pick them, you know what you're finding? You would be finding this right here. You would find the equation to this line right here, which is obviously too what? Too steep. Guys, question? Okay, please listen. People are behind you trying to listen. Okay, so this green line, if you pick that point, you just messed up your problem. Pick 2 points on your line. So here's me thinking, well, I suppose I should pick, this one's a good one, right? And that point corresponds to 60, 105. 60 years, 105. You see how this says 500 back here, guys? You know, this, to me, when these numbers are so large, I just want to work with the easiest number I can work with. So I'm going to leave off that 500. I'm just going to go there, 105,000. I'm really just kind of getting to the nearest thousands that I'm paying. I can only do this because these numbers are enormous. It doesn't make a difference, 105, 500, or 105,000. Okay, here's what I don't want you to do. Please listen to this. Do not do this. Pick that point, and then pick a point right next to it. Don't do that. Go way down here and pick a point down in this area. And I like this one because it's pretty much right on it. So this one goes with, I think this one is the 0, 10. Yeah, this one's the 20. So that would be 20, comma, what do you think I'm going to put?
58.
I'm not going to put 58.1. I'm just going to make it easy for myself. 58,000. Okay, now, here's my question. Should you have exactly my numbers? Realistically, if you did this problem by yourself, would you have my numbers? No. Everybody in this room will probably have different points, different numbers, but your points are going to be so close to the line anyways, it won't matter in the end. It just won't. You guys will all have answers really close to my answers, and that's really all I care about. Okay, so you got a point, and you got a point, and now you have to write the equation.
On the slope.
Yeah, and that's always the first thing. You need a slope, and you need points, don't you?
Yep.
Okay, so let's go back up. All right, so the slope is going to be, take your 2 points, subtract your y's. I'm gonna go 105,000, take away 58,000 over 60 minus 20. I'm gonna get 40. I'm gonna get 47,000. Okay, the zeros would cancel there. If you want to do 4,700 divided by 4, go for it. What does that come out to? I can't do it in my head. I don't want to do it in my head. I want you to help me out. I think it's close to 1,200. 1175. Okay. 1,175, comma, is the slope. Now, hang on. What does it even mean? What's that slope mean? See, I don't have any units on there. That's why it doesn't. You probably can't answer that right now. Goes up that much. So it goes up 1,175 and over that much. But what's the units? The units.
1 year. Month.
So you're saying the bottom number is years?
Yeah.
What's the top number?
Month.
Okay, guys, you should have known that because wasn't this top number money minus money? So wouldn't that be this over 40 what? Years. So it stays the same. So the slope is what? It's $1,175 per what? Year. All it means is my house goes up $1,175 every year. That's all it means. Okay. You know what I got last hour when I did this problem? Last hour I got 1,333. How come? How come I got a bigger slope last hour?
A different trend line.
It was a different trend line. It probably was more like this last hour. This hour is more like this. Not much difference. But just this much makes about $100 more, I guess. Okay, so there's your slope, right? Have you written the equation to your line? No, this is not the equation. This is just your slope. So to write the equation, you would need point slope form. There, that's what you need. In place of the m, you'll put what? 1175, right?
Just do this one with what you have.
Say that again.
Can you just put it right in the point slope?
Why?
Because we have this slope in
No, I didn't use 23,000. I didn't, you know, if you would have used 23,000, you probably could have got away with that. I didn't use it, though, so I can't. Okay, x minus, which point do you want me to use? This one or this one? See, and this is where you guys are all a little different. You're picking different points than I'm thinking. Okay, we're going with this one. So x minus the 20 equals y minus 58,000. Okay, and now you got to solve for y. Whoops, sorry. And if you do that, you're going to get y minus 58,000 equals 1175x. Take away, ouch, I don't know. What is that? 1175 times 20?
23.
Yeah? 11,750 times 2. 23,000 what?
500.
500. 23,500 negative, right? And then you slide the 58,000 over. How do you slide it over? Add it. Okay, so you add it. And add it here, 58,000. And you get 1175x plus, oh, 58,000, take away 23,500.
Negative 34,722. Wait, why did I get? Something's weird there.
Say again.
Hold on, no, I
30. 34,500, right?
Yeah.
Okay, comma. So that's my equation to my trend line. All right, so now the question 4 says this. And by the way, I still want to keep saying this to you. You will not get that answer. That's my answer. You picked 2 points on your line. Your 2 points would get you close to my answer. Okay? Now, they want this. What's the median home price in what year?
2020.
2020. Well, they're telling you that's the year. Where do you put the year? In for X or in for Y? What? X. Didn't the X value stand for years? So you have to put this in for this, right? But what do you put? Do you put that in or do you put something else in? 80. Yeah, put 80 in because 2020 was 80 years after we started. So now you have to take your calculator and basically punch it in. And this is Y. And remember, Y stood for the median home price.
128,500.
Okay. I'm going to write this below it. Median home price. What year? In 2020. So this is actually, that's not the answer. The answer was this one right here. Okay? Hey, you know what? We've been doing this problem for like almost 10 years. These books are almost 10 years old. 10 years ago, what was it? 2006. In 2006, when I saw these answers, 130,000 for a house, it seemed reasonable. Are you guys up on your home prices?
You're like
What's the median home price in Grand Forks? Just guess.
200,000.
Somebody said 250. You said
200.
200. I would go close around that 180 to 220. You know what I'm saying? And 10 years ago, we were predicting this, thinking this is probably what it's going to be. So if home prices really went skyrocketing, yeah, yeah, they've shot up quite a bit. This isn't even close. You go to Florida right now, hey, this is 2020. They're saying that's like 40 years from now the prices will be this. They're not this. They're already way past this. It's amazing how much home prices have gone up. Okay? So this is now very unrealistic. 10 years ago, we looked at this answer and thought, yeah, that could be that price. Kind of seemed expensive, but now you're thinking it seems cheap. Last question. About what year would the average home price reach what?
200,000.
200,000. Yeah. Now you got to put it in for the other variable. Put it in for Y. So 200,000 goes in for Y. X you don't know. I can't remember the y-intercept. 34. Is this it? Right? Okay. So now you're solving for X, and X stands for the time. So slide this over by doing what?
34,000.
You'd end up with 100.
66. Or
65, 500
whoops.
equals 11,
No.
75. Do the division.
It's equal to 140.
How much?
140. And then 140 equal to our little scale is 2080.
2080. Okay.
Yep.
Well, here's the deal. That answer, 140, that's, you got to remember what your X stood for. Your X stood for the number of years after after 1940. You'd have to take this, go back to your 1940 and add the 140 onto it. We're talking what year?
2008.
The year 2080. That's when they should be around 200,000. Now, you know what I got last hour? Last hour I got the year 2066. So guys, is this gonna always be dead on? No, because most of you will do this. You'll tilt your line a little bit more or a little less. And as you tilt your line, the farther into the future you go, the more off you are. You can't, the slope of the line will determine the future. And if you're too steep, you're going to predict too high. And if you're too flat, you're going to predict too low. So really, nobody knows if we're right or wrong. But all I know is this. I will look at all your work, and I'll make sure you're doing the work, and I'll make sure your slope is close to mine, and your y-intercept close to mine, and your prediction is close to mine. That's all I can do. I can't really say, no, your answer's wrong because you don't have 75. How do I know what the answer is? I don't. It's a trend line. I don't know what the answer is. But I do know if you're on the right track. Okay? All right. Here we go. Pay attention. You have 3 problems. I'll do this. You don't have to do number 3 because that's the graphing calculator problem. That'll be tomorrow. 1 and 2 are on your own. They're scatter plots. Draw a trend line, write the equation, and so on. How many problems?
2.
Can you get it done?
Yep.
One, two. Oh, sorry. Hand one back. Hand one back. Okay, number 1, so you know. Hey, listen. Number 1, there is no story. It's just graphs and ordered pairs. It's going to be a scatter plot. There's no story to go with it. You just write the equation and then you're done. Number 2, there's a story. Life expectancy for people born in various years. And then it says let x equals 0 correspond to what year?
1950.
1950. So they're telling you to change the x coordinates. And that's it. Write the equation to all these, to both scatter plots. Over here, did I get everything? Blue worksheet 2.4? Nope. Okay, you guys quit talking and actually do some work.